Okay, I just recopied the integral we were at when we had left off. I had said I was going to do this whole thing using a u sub. It looks like we're going to want u to be 4r squared plus 1, this quantity under the radical, which means that du will be 8r dr. So I'm going to do a couple of things in the next line. First of all, both of these terms do have an r in them, so I'm going to just factor out the r that I'm going to absorb into the du. I'm also going to multiply on the inside by an 8, which means I'll counterbalance on the outside with a 1/8, so that I've just multiplied by 1. So we're going to have 1/8, the integral from 0 to 2 pi, the integral from, I'm going to just rewrite things first and then I'll do the u sub. So I'm still writing it in terms of r's and thetas. 0 to 1. I'm going to factor out that r. So this is just going to be a 4r squared plus 1 under the radical, minus, I'm factoring out 1r, so that's an r squared, root 4r squared plus 1, and then times 8r dr d theta. So there's my du right there. Okay. Now, this piece is going to be nice. That's just a root u. That's also a root u. But I've got this extra factor of r squared. Well, I can figure that out. If u is 4r squared plus 1, r squared is u minus 1 over 4. So I'm just going to rewrite that extra piece in terms of u as well. So we'll have 1/8 integral from 0 to 2 pi. Integral from the u value at 1 is going to be 0 plus 1 is 1. I'm sorry, the u value at 0. The u value at 1 is 4 times 1 squared is 4, plus 1 is 5. This is just root u, which I'll write as u to the 1/2, minus r squared, we said, was u minus 1 over 4. And this is root u, which is u to the 1/2. That's all du d theta. Okay, now I've got this product here, but fortunately, I know how to multiply. So I don't have a nice rule for integrating that particular product, but I do know how to simplify the multiplication. So this is 1/8 integral 0 to 2 pi, integral 1 to 5, u to the 1/2, minus, I'm just going to write this as 1/4. Let's see, that's going to be u to the 3/2 minus, actually let's just distribute that 1/4, minus 1/4 u to the 1/2 du d theta. Let's go ahead and combine the u to the 1/2. We've got a full copy minus a quarter of a copy. So that's going to be 1/8 integral 0 to 2 pi, integral 1 to 5. I'm going to have 3/4 of u to the 1/2 minus 1/4 u to the 3/2 du d theta. Definitely a lot faster than doing a trig substitution, which again is just brilliant conceptually, but tedious to do. There we have it. Okay, so I'm going to get 1/8, the integral from 0 to 2 pi. Let's see, here I'm going to get 3/4 times u to the 3/2 multiplied by the reciprocal powers of the power, so times 2/3, minus 1/4. Now here I'm going to get u to the 5/2 divided by 5/2 is multiplied by 2/5. All of this is evaluated between 5 and 1, and then we still have to integrate with respect to theta. So we're going to have 1/8 integral from 0 to 2 theta. It's going to be what I get at 5 minus what I get at 1. And then we still have to integrate that with respect to theta. Okay. Now, here I can cancel my 3's. The 2 and the 4 will reduce. So the coefficient here is just 1/2. And then 5 to the 3/2. Minus, here I can cancel the 2 and the 4, so that coefficient becomes 1/10, 5 to the 5/2. Now, remember my rule for fractional exponents. The 2 on the bottom tells me to take the square root. Square root of 5 is irrational, so totally fine not to simplify it. If this were a 4 here, I'd say, oh, the square root of 4, that's just 2, and I'd go ahead and simplify it. Okay, minus what I get at 1. And what's nice is 1 to any power is just 1. So I'm just going to get 1/2 minus 1/10 when I plug in the 1. All right, all of that is just a constant, okay? So I'm going to get that constant times this constant times 2 theta. Let's just see if we can't simplify a little bit. I'm going to just distribute the negative here and find a common denominator. So this would be negative 1/2 would be 5/10 plus 1/10. So that's negative 4/10 or negative 2/5. So when I integrate, I'm going to get 1/8 times this constant inside is 1/2 of 5 to the 3/2 minus 1/10 of 5 to the 5/2 minus 2/5. That, all of that was this constant, and then times 2 pi. Not a whole lot of simplification to do. I think I'm going to cancel the 2 with the 8 to get a 4 there. And then I'm going to say I have a 4th of 1/2 5 to the 3/2 minus 1/10 5 to the 5/2 minus 2/5 times pi. So let's just make that a pi over 4 and combine the pi and the 1/4. That's definitely simplified enough at this point. All right, good stuff.